Forget alternating current. Seriously, just for a moment, forget hydroelectric dams.
Yeah, put those aside.
Today, we are going deep into the mind of the man who offered the U.S. government a way to melt bomber engines mid-flight from 100 miles away.
With an invisible beam, no less. And he didn't stop there. He built this little, desktop machine, supposedly small enough, that he claimed could literally shake the world.
Nikola Tesla. Okay, so most people know the name, maybe the AC/DC wars, but this is different.
Way different. He was much more than just the father of the electrical grid. We've been digging through his Colorado notes, his later patents, government files even.
The juicy stuff.
Exactly. And what emerges is this picture of a man chasing a completely alternative technological future.
Yeah.
One based on, tapping the universe's own energy.
Building these impossible machines, engineering space itself, it sounds like science fiction.
It really does. But the kicker, the proof that this wasn't just, scribbles in a notebook. When he died in 1943, his final, most potentially explosive inventions.
Teleforce plans, his gravity ideas, all those notes.
Swiftly seized, microfilmed by the U.S. government, locked away.
Okay, so that's our mission today. We're going to unpack this, give you a comprehensive, hopefully awe-inspiring,
long overdue deep dive of Tesla's suppressed genius.
Yeah, what took us so long?
We want to explain his most revolutionary, most practical, and, allegedly suppressed designs.
We're tracing that ambition, starting with the pure mechanical brilliance that honestly should have powered the whole 20th century.
Right, and then following that thread all the way up to his dreams of literally hooking our machines into the wheelwork of nature, as he put it.
And the hook, the place we start, it's not cosmic rays, not yet. It's an invention that should have been in every single ship, every factory 100 years ago.
An impossibly simple, ridiculously powerful bladeless engine. Claimed 97% efficiency.
Let's unpack that. The ultimate machine.
Tesla's mechanical thinking, it really started from this deep dissatisfaction, maybe even disdain for how inefficient everything was.
Right. He looked at engines, turbines.
Yeah, and he wanted to just throw out the standard approach. The reliance on shocks, sudden changes, pistons banging back and forth, blades chopping through fluid.
Because if you think about the engines back then, early 20th century, combustion engines, steam turbines, it's all violent action, isn't it?
Totally. Piston slamming creates vibration, wasted heat, turbine blades getting hit by high-pressure steam. That causes massive turbulence. It's just inherently lossy.
So these systems weren't just inefficient, they were complex.
Super complex.
Yeah.
Expensive to maintain, always wearing out. Tesla saw that forcing a fluid, steam, gas, whatever, to change direction suddenly or hit a blade just wastes tons of energy. It's fighting against itself.
Okay, so his goal was different. He wanted power, but smoothly, using the natural flow.
Exactly. Let the fluid follow its path of least resistance. No need for vanes or paddles forcing it around. Smooth, gradual, almost frictionless transfer of energy.
So bypass the impact. Use something subtler.
Precisely. A molecular kind of energy transfer. And that whole philosophy, that search for smooth efficiency, that's what led him straight to the ultimate machine.
And the machine itself, when you first see diagrams, it almost looks like a joke, right? There's nothing in it.
It's startlingly simple. The rotor is just a stack of thin, smooth discs, like really thin, maybe German silver or something smooth, stacked on a shaft.
No blades, no vanes, no complicated curvy bits.
None. Zero.
Right.
The genius was using fluid dynamics principles that other engineers actually saw as problems, as things to overcome.
Okay, so how does it work without blades hitting anything?
It runs on two really subtle principles. Adhesion and viscosity.
Adhesion, like tape. The fluid sticks to the disc.
Pretty much, yeah. The steam or gas wants to cling to the surface of those smooth discs.
And viscosity, that's like thickness, like honey versus water.
Exactly. It's the internal friction within the fluid itself. So you inject the fluid tangentially, right at the edge of the discs.
Tangentially, so it skims along the edge.
Right. It doesn't slam into anything. Because of adhesion, it starts sticking to the discs. Then, because of viscosity, that sticky layer of fluid starts dragging the next layer along. And the next.
Ah, so the layers of fluid drag each other, and because the first layer is stuck to the disc?
The whole stack starts to spin. The fluid spirals inwards towards the center exhaust, constantly transferring its energy to the discs through this Purely molecular action, he called it.
Wait, so the energy transfer is basically frictionless, ideally, and it uses viscosity, something engineers usually fight against because it causes drag, as the main way to make it spin.
That's the beautiful counterintuitive insight. He turned a loss mechanism into the primary driver. No impact, no shock, just molecular drag.
Okay, that's clever. But the performance numbers you mentioned, they sound unreal.
They are staggering. Get this. He developed 110 horsepower from a rotor that was only like 9 34 inches across and 2 inches thick. Tiny.
110 horsepower from something that small.
And he claimed a slightly bigger version could easily hit 1,000 horsepower. Think about the power density.
That's insane for the time.
He built a 200 horsepower double turbine, 2 rotors back-to-back that weighed only 88 pounds.
88 pounds?
Yeah, that's about 0.1 pounds per horsepower. For a steam engine in the 1910s, that's revolutionary, especially for things like ships or even early aircraft concepts.
Okay, but the efficiency number, that's the one that just breaks my brain. 97%.
He claimed up to 97% of the energy in the steam could be turned into power at the shaft.
Conventional turbines back then? What were they hitting? 50, 60% if they were lucky.
If they were lucky. And they were usually huge, complex beasts needing massive cooling systems, complex gearing. Tesla's was claiming near-perfect energy conversion.
Almost no wasted energy. How?
Well, part of it is the lack of blades. No fragile parts to break off or warp. This thing could run hot. He said continuously at 2,500 degrees Fahrenheit, maybe even bursts up to 3,000 degrees.
And running hotter means better fuel efficiency, right?
Absolutely. You get roughly a 10% boost in fuel efficiency for every few hundred degrees Fahrenheit you can raise the operating temperature. This machine loved heat. It was designed to run hot, hard, efficiently, and sip fuel compared to the alternatives.
Okay, so durable, powerful, light, incredibly efficient. What else?
Reversibility. This was huge for ships. Conventional steam engines and turbines needed complex, heavy, extra gearboxes just to go in reverse.
Right, like a transmission.
The Tesla turbine. You just change which inlet port you feed the steam or gas into. One port spins it one way, the other port spins it the other way.
Yeah.
Naturally reversible. No extra hardware needed. Perfect for ships.
Okay, I have to ask the obvious question then. Simple, powerful, robust, hyper-efficient. Why isn't this technology everywhere? Why aren't our cars using miniature versions of this? Why didn't ships adopt it wholesale?
That's the million-dollar question, isn't it? And that leads to the suppression angle. Tesla tried. He formed the Tesla Propulsion Company, built prototypes.
But it didn't take off.
It completely stalled. Think about it. Here's a practical, commercially viable technology. It's simple, cheap to build, needs minimal maintenance, and lasts potentially forever because there's little to wear out.
That sounds bad for business if your business is selling complex machines and replacement parts.
Exactly. It fundamentally threatened the entire established industrial complex. Companies like Westinghouse, General Electric, the massive industries built around complex, failure-prone, but very profitable conventional engines and turbines.
They had zero interest in this.
Less than zero. Why would they want a simple 97% efficient machine that rarely breaks down taking over the market? It was the opposite of a business model based on planned obsolescence and continuous servicing.
So this incredible invention, arguably one of his most practical and world-changing, basically got sidelined.
Sidelined, underfunded, and ultimately ignored. Tesla's was left, as usual, struggling for money, despite having designed what should have been a cornerstone of 20th century power.
Okay, so the ultimate machine was amazing, but it was still, harnessing steam, gas, conventional stuff, just doing it way better.
It was grounded in mechanics. But Tesla's vision quickly went way beyond that. He started thinking bigger, much bigger.
From efficient engines to the planet itself.
Exactly. He developed this radical, deeply held conviction that the Earth wasn't just rock and dirt. It was a gigantic electrical object, a highly and permanently charged body.
Like a giant battery floating in space.
Sort of, yeah. More specifically, he saw it as a massive air condenser, or capacitor in modern terms, an existing perfect medium for sending energy and messages anywhere on the globe, wirelessly.
Wow. Okay, that's a leap. How did he plan to use this planetary condenser?
This idea came from years of studying planetary electrical dynamics, lightning, atmospheric electricity, and it led to his most ambitious and ultimately, heartbreaking project, the world system.
The world system. And the heart of this was the magnifying transmitter, right? We hear about Tesla coils, but this was something else.
Oh yeah, way beyond a standard Tesla coil. This was a highly specialized transformer, designed specifically, as he put it, to excite the Earth, to pump electrical energy into the planet's existing charge.
Excite the Earth. What does that mean practically?
He claimed, during his experiments out in Colorado Springs.
The famous ones.
Right. He claimed he used his transmitter to pass a current through the Earth, powerful enough to light over 200 incandescent lamps. Not near the transmitter, but around the globe.
Wait, light lamps thousands of miles away, using the Earth itself as the wire?
That was the claim, manipulating the Earth's natural electrical field on a planetary scale.
Okay, that explains Wardenclyffe, the giant tower on Long Island.
That was the physical embodiment of the dream. J.P. Morgan, the financier,
The big money.
he put up $150,000. Now, Morgan thought he was funding a worldwide wireless broadcasting system, sending messages, maybe controlling markets globally, a communication monopoly.
But Tesla had a bigger, more disruptive idea in mind.
Tesla's real goal, the non-negotiable one for him, was global free energy.
Free energy, not just communication.
Exactly. The Wardenclyffe Tower, that huge 187-foot steel structure with the massive copper dome. It wasn't just for signals. It was designed to pump millions of volts of electrical energy into the Earth's standing charge.
Topping up the Earth's battery.
Essentially, yeah. And the idea was, once the Earth was sufficiently excited or charged up, anyone, anywhere on the planet could just tap into that energy, put up a simple receiver tuned to the right frequency, and draw off power.
Like tuning into a radio station, but for electricity.
Precisely. Free wireless power for everyone.
And J.P. Morgan. I'm guessing he wasn't thrilled when he figured that out.
That's the understatement of the century. Morgan was a titan of industry, of finance. He built empires on things you could control, meter, and bill.
And you can't really put a meter on the entire planet's electrical field.
Exactly. There's no profit in free energy for everyone. Once Morgan realized Tesla's true aim wasn't just communication, but unmeterable power, he instantly pulled the plug.
Just cut off the funding?
Completely. The project ground to a halt. Not enough money to finish it. Not enough money to run it. And that was basically the end of the dream of free, wireless global power.
First, the perfect engine gets sidelined. Then the free energy system gets deliberately defunded. You start to see a pattern.
A pattern of brilliant, world-changing ideas running headfirst into the realities of finance and control.
Okay, but his work in Colorado Springs, it wasn't just about trying to transmit power, was it? He was also listening to the Earth, studying its electrical behavior.
Oh, absolutely. Those experiments were incredibly sophisticated. High potential, high frequency alternating currents, millions of volts, hundreds of thousands or millions of cycles per second. He was really probing the planet's electrical structure.
And what did he find, besides the power transmission idea?
He figured out that certain waves, very long ones, about 3 to 4 miles long, could travel very efficiently through the ground, through the Earth itself.
Like ripples on a pond, but electrical ripples through the planet.
Kinda, yeah. He realized the Earth acts like a giant resonant cavity, like an electrical bell. If you strike it electrically at the right frequency, it rings.
It has a natural hum.
A natural electrical hum. And he got even more interested in atmospheric effects. He started noticing connections between electrical phenomena and the weather.
Weather control. Are we going there?
Well, he theorized about it. He observed that major cosmic events, like big solar flares, seemed to cause the Earth's electrostatic charge to vibrate rapidly.
Okay.
And he thought these planetary electrical vibrations could cause significant sudden changes in temperature and air pressure locally, potentially triggering storms or allowing for localized weather modification if you could control the vibrations.
Wow. So influencing weather by tuning the Earth's electrical field. That's ambitious.
Extremely. And speaking of tuning the Earth, get this. He made these predictions about the Earth's fundamental resonant frequencies, the frequencies at which the planet naturally rings electrically. He calculated them to be around 6, 18, and 30 hertz. Extremely low frequencies.
6, 18, 30 hertz. Did science ever follow up on that?
Decades later, in the mid-20th century, scientists discovered what's now called the Schumann resonance. These are the resonant modes of the electromagnetic cavity between the Earth's surface and the ionosphere.
And the frequencies?
The fundamental modes are right around 8, 14, and 20 hertz.
Whoa. So Tesla, back in the early 1900s, was incredibly close. He basically nailed the concept and got remarkably close to the actual numbers.
It's uncanny. It proves he wasn't just guessing. He was somehow measuring or calculating the electrical heartbeat of the planet. He was literally trying to tune into the Earth.
Okay, but even that wasn't the ultimate goal, was it? Transmitting power, tuning the Earth?
Mm-hmm.
He went further.
He went way further. This pushes beyond engineering, maybe even beyond physics as we commonly understand it. He became obsessed with finding energy that was obtainable anywhere. not just on Earth, but anywhere in the universe.
Energy from empty space.
That's the gist of it. He wrote, and this quote really captures it, "Throughout space, there is energy. Is this energy static or kinetic?"
Static, like potential energy, or kinetic, like moving energy.
Right. And he concluded, if kinetic, then it is a mere question of time when men will succeed in attaching their machinery to the very wheelwork of nature.
Attaching our machines to the wheelwork of nature. So he believed space wasn't empty.
He believed the vacuum was filled with inherent perpetual motion, kinetic energy, like the universe itself is constantly spinning, churning, full of energy. In other words, the ether. He said, the eternal recipient and transmitter of this infinite energy is the ether. The recognition of the existence of ether and of the functions it performs is one of the most important results of modern scientific research.
And he wasn't trying to create energy from nothing.
No, he was trying to figure out how to tap into the energy that's already there, like putting a tiny gear onto a giant invisible cosmic flywheel and drawing power from its rotation.
Energy from the void, tapping the kinetic energy of the universe itself.
That was the ultimate vision. Infinite clean energy available everywhere just by understanding how to connect to the fundamental motion of the cosmos.
Okay, if that concept alone hasn't blown your mind, I don't know what will. We've gone from a 97% efficient engine to global wireless power to tuning the Earth's heartbeat and now tapping the universe's hidden energy.
It's quite a journey.
It really is. And look, if you are finding this as fascinating as we are, if you want us to keep digging into these incredible, often overlooked ideas, do us a huge favor. Hit that like button, subscribe to the channel, and maybe even consider joining our memberships.
Yeah, it genuinely helps us keep the lights on, keep researching, and keep bringing these deep dives to you. We need your support to keep exploring this stuff.
Seriously, every click helps. And trust me, you absolutely do not want to miss what's coming up next. We're talking about the invisible beam weapon.
Teleforce.
Oh!
The death beam.
And the machine that could supposedly cause targeted, localized earthquakes. Stick around.
All right, so if the world system was about power for humanity, some of Tesla's later ideas, especially those he talked about in his rather dramatic annual birthday press conferences.
He did love a good show.
He really did. These later concepts seem much more focused on power over things, defense, potentially offense. And these are the ideas that really got the government's attention after his death.
Which brings us straight to Teleforce, the so-called death beam.
All right, now first things first, we need to be super clear. When he offered this to the U.S. government around the 1940s, as this ultimate defensive shield, it wasn't a laser.
Not like Star Wars.
No, definitely not light. It was conceived as a beam of particles. Microscopic bits of matter like tungsten accelerated to incredible speeds.
Particle beams. Okay, how fast, how powerful.
The technical details that have surfaced, some possibly from those seized papers, suggest he was talking about beams operating at potentials up to 50 million volts.
50 million volts?
Yeah, propelling these tiny particles at speeds around 350 miles per second.
That's incredibly fast. What was the point? What could it do?
He claimed that just a dozen of these Teleforce projectors placed strategically across the U.S. borders could create an impenetrable shield against aerial attack. Any enemy bomber flying into the beam.
What happens?
The sheer kinetic energy and electrical charge delivered by these high-speed particles would instantly melt its engines or detonate its bomb payload. Poof!
An invisible wall of death, basically.
Right.
A high-tension radiant curtain of protection, I think he called it.
That's the phrase. An absolute defense. But, and this is crucial to the story, when he offered it, he had conditions. Big ones.
Oh, what did he demand?
He insisted that the government had to trust him completely, give him the resources, step back, and let him build it his way. His exact stipulation was that he would suffer no interference from experts.
No interference from experts. Why? Was he just arrogant?
Maybe partly, but his reasoning was probably that experts of the time would immediately try to change his radical design, try to fit it into their conventional understanding of physics, and in doing so, they'd destroy its effectiveness.
Yeah.
He believed only he understood the specific principles needed to make it work.
Okay, so he offers this game-changing weapon but demands total control. But wait a second. Was this just a theory? A blueprint? Or did he actually build anything? Is there evidence it was more than just an idea?
This is where it gets really murky and, frankly, a bit dark.
Yeah.
The strongest evidence that this was more than just theory comes from records of him disclosing the technology to others.
Others, not the U.S. government.
Before he made the formal offer to the U.S., government files confirm that back in 1935, Tesla provided plans and detailed specifications for producing these high-voltage particle beams to the Amtorg Trading Corporation.
Amtorg. I know that name. That wasn't just some import-export company, was it?
Not even close. Amtorg was widely known, even then, as a primary front organization for the Soviet Union in the United States. It was involved in technology acquisition, economic dealings, and, yes, espionage.
So Tesla sold the plans for his death beam to the Soviets, or at least the Soviet front.
The record shows he acknowledged receiving a $25,000 fee, a huge sum in 1935, for disclosing the technical details to Amtorg.
Wow. Okay, that changes the context entirely. The plans for his ultimate American defensive weapon were already potentially in the hands of a foreign and increasingly adversarial power years before he offered it to the U.S.
Precisely. You can imagine the alarm bells that must have gone off within U.S. intelligence circles when they eventually discovered this. It adds a whole new layer to why they might have been so eager to seize all his papers immediately upon his death in 1943. It wasn't just about protecting his genius, it was about damage control.
Understanding what secrets might already be out there. Heavy stuff.
All right, moving from a potentially weaponized technology to a natural phenomenon that seems related, but much weirder. Ball lightning.
Ah, yes. One of nature's great mysteries. People report seeing these glowing spheres, right?
Yeah. Descriptions vary, but typically it's a bright incandescent ball, maybe inches to a foot across, perfectly spherical, just floating silently, like a soap bubble made of light.
Totally mesmerizing, but also incredibly rare and unpredictable.
And potentially dangerous, right? They don't last long, maybe fractions of a second, maybe longer.
And then they can either just fade away, or sometimes they explode. Quite violently, apparently, causing damage like a small bomb if they hit something. So just a weird weather thing. Or did Tesla connect it to his work?
He absolutely connected it. He didn't just observe it. He encountered forms of it during his high-frequency, high-potential experiments in Colorado. He became fascinated by how the immense energy of a lightning strike could somehow get locked into this stable, spherical plasma form.
Locked energy, like containing lightning in a bottle.
Exactly. He saw a direct link between the physics of ball lightning and the principles behind his teleforce beam and that curtain of protection. It was about concentrating massive amounts of energy and stabilizing it in a specific region of space.
So if you could understand and control ball lightning,
you'd have a way to create localized, potentially destructive balls of energy on demand. It's another form of controlled energy projection.
Okay, from particle beams and ball lightning to something maybe even more terrifying in its implications, the earthquake machine. Telegeodynamics.
This is the one based on his mechanical oscillator. He claimed this device, properly tuned, could literally shake the world.
The device itself, though, wasn't huge, right? It wasn't some giant jackhammer.
No, apparently it was relatively small and compact. The design cleverly combined a piston, driven by steam or compressed air, with the moving part of an electrical generator.
A mechanical-electrical hybrid.
Yeah, but the real genius wasn't the power source, it was the control. He designed the electromagnetic part to maintain a perfectly constant frequency of vibration, even if the air pressure driving the piston fluctuated. Precise frequency control was key.
Why was the frequency so important?
Resonance. This is the hidden and frankly terrifying application. Everything has a natural resonant frequency, the frequency at which it wants to vibrate most easily. A bridge, a building.
Even the Earth's crust.
That was Tesla's idea with telegeodynamics. If you could build an oscillator, even a small one, and precisely tune its vibration frequency to match the natural resonant frequency of a large structure.
Like tuning a guitar string.
Exactly. A tiny push, applied repeatedly at just the right frequency, can build up enormous vibrations. Think about pushing someone on a swing. Small pushes at the right moment send them higher and higher.
So apply this oscillator to a building.
And match its resonant frequency. Even the small mechanical force from the oscillator could be amplified exponentially, potentially causing catastrophic vibrations, shaking the building apart.
Or apply it to the ground, find the resonant frequency of a particular geological formation.
And potentially trigger a localized earthquake. That's telegeodynamics. Using mechanical resonance as a weapon or a tool of immense power.
Did he?
Yeah.
Did he ever test this? Please tell me he didn't actually try to cause an earthquake.
Well, there's a famous, possibly apocryphal story. The anecdote goes that he tested a small prototype oscillator in his New York lab. He supposedly clamped it to a steel beam in the building's structure. As he tuned the frequency, he hit the building's resonant frequency. The whole building started to shake violently. Equipment fell off shelves, plaster cracked. The story continues that the shaking became so intense, neighbors called the police. Before they arrived, Tesla, realizing what he'd unleashed, supposedly grabbed a sledgehammer and smashed the device to stop it.
Wow. Whether the story is true or not, it illustrates the principle. Tiny force, right frequency, potentially catastrophic result.
It's basic physics resonance, but weaponizing it on that scale.
Yeah.
That's a chilling thought. Unparalleled strategic control, potentially.
Okay, so we've covered the efficient machines, the earth power, the potential weapons, particle beams, resonance devices. Where did Tesla go next? Because it seems like his later work got even more fundamental.
It really did. If the suppressed applications were about controlling energy and matter in somewhat conventional, albeit advanced ways, his final research phase seems to dive into the very fabric of reality itself. We're moving beyond standard physics, into territory that touches on non-Euclidean geometry and the nature of space.
Okay, non-Euclidean physics. This sounds complicated. Scalar physics.
Well, Tesla's thinking wasn't entirely aligned with, say, Einstein's relativity, which became the dominant paradigm. His influences were different, maybe older, more philosophical. Think Plato, Kepler, Leibniz, and especially the mathematician Bernhard Riemann.
Riemann, what's the connection there?
Riemann's geometry was revolutionary because he basically said, let's ditch the old axioms. Forget the fixed rules about parallel lines and triangles that we inherited from Euclid.
Throughout the geometry textbook.
In a sense, yeah. Riemann argued the only valid starting point for geometry is the process of transformation itself. How one state or order, what he called a manifold of order n, changes or develops into the next state, n+1.
Okay, hold on. Manifolds, transformations. ELI5 for this for us. What does that actually mean?
Think of it like this. Standard geometry sees space as a fixed stage, like an empty box where things happen. Riemann, and Tesla following him, saw space as dynamic. It's not a box. It's more like a flexible medium. And its properties, what we perceive as distance or dimension, are defined by the action or the energy within it.
So space isn't empty, and its shape depends on what's happening in it.
Exactly. The distance between 2 points isn't just empty space. It's a measure of the energy density or the transformation process occurring between them. For Tesla, this was key to understanding the vacuum. It's not nothingness. It's the geometric expression of underlying energy fields.
Okay, that's a different way to look at space. How does that relate to energy?
It connects directly to this idea of a nigentropic universe.
Negentropy, opposite of entropy.
Right. Most of physics focuses on entropy, the tendency for everything to run down, become disordered, chaotic, heat death of the universe, all that.
The universe is winding down.
But Tesla, influenced by people like Kepler, seemed to lean towards negentropy. The idea that the universe isn't just running down, it's also constantly self-organizing, self-developing, like a living system that actively resists chaos and builds complexity.
So the universe is constantly getting fed energy somehow, not just losing it.
That seems to be the implication. It points back to his idea of the void, the vacuum, not being empty. He talked about it being filled with potential, with massless charges floating in constant acceleration. Not matter as we know it, but pure potential, pure dynamism, constantly organizing itself. He was looking at the space between the stars, not just the stars themselves. And this focus on the fundamental nature of space, this dynamic vacuum, naturally led him into thinking about gravity differently. His later work, formalized in a 1937 paper apparently, dealt with a dynamic theory of gravity and also cosmic rays.
A dynamic theory of gravity, so not just masses attracting each other.
Seemingly not. More like gravity being an effect of these underlying energy flows in the dynamic vacuum. But to actually test some of these high-frequency, high-energy ideas related to the vacuum, he realized he needed something special, an engineering solution.
What did he need?
He needed a way to create a near-perfect vacuum, far beyond what mechanical pumps could achieve. He conceptualized what he called an electrical vacuum pump.
Electrical vacuum pump. How would that work? Not sucking air out?
No. Pushing it out, or rather throwing it out. The idea was to use incredibly high electrical potentials inside a bulb or chamber.
Millions of volts again?
Potentially, yeah. High enough to literally ionize and then electrostatically repel any remaining air molecules or atoms right out of the container. Molecular expulsion, leaving behind an almost truly empty space.
An ultimate vacuum. Why go to such extreme lengths? Why did he need a vacuum that perfect?
For efficiency, particularly in light production. He claimed that if you combine this extreme vacuum with his high-frequency currents, you could create light vastly more economically than incandescent bulbs, maybe 20 times more efficient.
20 times? How? What does the perfect vacuum do?
He described taking a tiny button of a very refractory material like carborundum inside this ultimate vacuum. Then you hit it with massive high-frequency energy because there's virtually nothing else in the bulb, no gas molecules to interfere or absorb energy. Almost all the energy goes into heating that tiny button to extreme incandescence. It would form a stable, protective photosphere around itself, glowing incredibly brightly with minimal energy input.
So nearly 100% of the electrical energy becomes light, with almost no waste heat or other losses because there's nothing for the energy to interact with except the target button.
That was the idea. Ultimate efficiency through an ultimate vacuum. Engineering matter and energy at a fundamental level.
Right. Dynamic gravity, perfect vacuums, light from tiny buttons. You'd think that's the limit, right? But there was one more frontier he was apparently exploring.
There was. And this one really bridges the gap between physics and something else entirely. His final, perhaps ultimate ambition was testing the theory of thought transmission.
Thought transmission, like telepathy. Mind reading.
Essentially, yes. Direct mind-to-mind communication. He theorized that if he could truly master these fundamental forces, the electrical nature of the Earth, the resonances, the properties of the vacuum, he could potentially use them to transmit thoughts or information directly between human minds.
How? Using radio waves?
No, not conventional radio. More like tuning into the resonant frequencies of the brain, or using the Earth itself as a medium, leveraging the same principles he explored for wireless power, but for consciousness itself.
Okay, that's out there, even for Tesla, facilitating telepathy through physics.
It was the final frontier for him, it seems. Connecting not just machines, but minds, using the fundamental forces of the universe he spent his life trying to understand and harness.
Which brings us full circle back to his death in that New York hotel room in 1943 and what happened immediately after. All these incredible ideas, from the practical engine to the cosmic theories. What happened to the proof, the papers?
As we mentioned, the official story is clear. His belongings weren't initially grabbed by the FBI, despite the rumors. The Office of Alien Property Custodian stepped in first.
Why them? He was a naturalized U.S. citizen by then.
He was, but he was born in the Austrian Empire, modern-day Croatia. And during wartime, that office had broad powers over property, with any potential foreign connection or significance, especially involving advanced technology. They seized everything papers in his hotel safe, but also tons of material he had in storage. Decades worth of notes, blueprints, prototypes.
And the FBI, they just stayed out of it.
Not quite. Yeah. The FBI was notified immediately, understood the potential importance, especially given the Amtor connection and the defense implications. FBI files confirm federal authorities, likely from military intelligence or other agencies, did access his stored materials.
And they just looked.
The record specifically mentioned them taking numerous photographs. Given the technology of the time and the context, this almost certainly means extensive microfilming. They documented everything.
So copies were made before the bulk of his physical papers were eventually sent to Yugoslavia. Years later, to the Tesla Museum, the U.S. government got its own copies.
That seems undeniable. They acquired, studied, and documented his complete works, including all the electrical formulae, designs, etc., before letting the originals go.
And the final question, does any of this stuff, especially the more out-there ideas like teleforce, still matter? Is it just historical curiosity?
Not according to ongoing research trends. It's widely acknowledged that U.S. defense research, particularly in areas like directed energy weapons, still actively contains studies and build upon Tesla's foundational concepts for particle beams, those high-tension radiant beams.
So his death beam idea wasn't entirely crazy.
Far from it. The science he was pioneering in the 30s and 40s, which seemed fantastical then, became a core area of classified military research decades later and remains so today.
Yeah.
His work on particle beams is still relevant, still being developed, albeit behind closed doors. So you look at the whole arc. The bladeless turbine running on molecular adhesion, the earthquake machine using resonance, the teleforce beam, the dream of free energy from the Earth, tapping the kinetic energy of the cosmos. It really is like glimpsing an alternate history, a technological path not taken.
A world powered differently, defended differently. It's incredible. Yeah. And that stipulation you made about teleforce, give me the money, trust me completely, and keep the experts away.
Yeah.
Was the world just not ready to trust a genius operating so far outside the box? Or was the kind of power he was tapping into free energy, potentially terrifying weapons, simply incompatible with the economic and political systems of the 20th century? A system built on metering power and controlling conflict.
It's a fundamental question. And it makes you wonder, what else is hinted at in those microfilm documents? Deeper insights into dynamic gravity, practical ways to achieve negentropy, maybe even the actual schematics for thought transmission. Secrets still waiting in the classified archives.
Still waiting for us, or perhaps someone, to finally catch up to the man who seemed to live a century ahead of his time.
A sobering thought to end on.
Definitely something to chew on. Well, that's all the time we have for this deep dive into the phenomenal, mind-bending world of Nikola Tesla. We really hope you found it as fascinating as we did.
Absolutely. Don't forget to hit like, subscribe for more deep dives like this, and check out the memberships if you want to support the channel.
Your support really does make these possible. Thanks for joining us, and we'll see you on the next exploration into the known and unknown.